Hello, and welcome back. So today we're going to start our newest unit, which is using transformations to prove congruency. So we've already talked a little bit about what the word congruent means, meaning it's the same size and same shape. And in our last unit, we talked about various transformations that will keep that size and shape. And so now we're going to jump into the first part of this unit, which is just using those transformations we used in the last unit, but in a sequence. So that means like using multiple transformations, one after the other, to be transformed from one pre-image to a new image. So that's what we're going to start talking about today, is that a figure can be transformed more than once to create an image. Now remember that image is like our final product, and the pre-image is the before. Okay? And so we talked about those different types of transformations, and one thing that we talked about was that when a rigid transformation is being used, the figures are going to keep their shape and their size. Okay? They're keeping that. Now, if it was non-rigid, it would not keep the shape or size. Okay, so a rigid type of rigid transformation would be such as a reflection, because it kept the same size and shape, a rotation, or a translation. Okay, all of those keep their size and their shape. Okay, so really in this part of the unit, we're just going to use multiple transformations each time. Okay, and so for example, we're going to take a look at this sequence. So we're starting with XY. So this is our pre-image. It's the OG. Okay, and then we're going to, this is the transformation that's being used right here. And we know that when you're adding to X and subtracting from Y, or doing vice versa, then it's a translation. So it's just being moved. Okay? And then this right here may give us something else. Okay? So it may be a rotation or a reflection. So we'll take a look at that here in a second. But if we were to take this sequence, so we start with A, B, C, D in this image, and we're adding 3 and subtracting 4. Okay, so that means for each point, so this point is going to go to the right 3, 1, 2, 3, and it's going to go down 4. So 1, 2, 3, 4. So this is where A prime is now going to be. And you'll do the same thing for each point, okay? So once you get that image, let's just see. B to the right 3 and down 4. C, right 3, down 4. And D, right 3, down 4. So then this is going to be our new image after this translation right here. Okay? But we also are asked to do something else, and it's negative XY. And so I can immediately notice that this is just reflected over the y-axis. So this is just a reflection over the y-axis. And that's where you end up with these new points. Okay? So that is a sequence of transformations. You did a translation, and then you did a reflection to end up with your final image. Okay? So it was moved by a translation. And we went, whatever is added to X is going to be how many units you're going to go to the left or right. And in this case, it's positive, so you're going right 3 units. And then you're going to go down 4 units, okay? Because that's what's subtracted from the y, and it's going down because it's subtracted, okay? So that is our sequence of transformations. So now let's try an example. So then the image was reflected, and we already talked about this, reflected over the y-axis, okay, to form the new figure. And that is the image, not the pre-image. The pre-image is the before, the image is the after. Okay, so then we have an example here. So we're going to draw the image after a given sequence. So I can already notice here that again we're adding something to the x. So this is going to be a translation. And then I believe that this is going to be a reflection over the x-axis. But let's see. So we're starting with these points, and we're adding 2 to our x, but our y stays the same. So basically everything's just moving over 2 points, okay? So this is now a prime, this is now b prime, this is now c prime, because y stays the same. And this is now d prime. Okay, so this is what our new figure is, okay? And then it says x negative y. So x is going to stay the same, y is going to now become negative. So we're just flipping this over the x-axis. So x stays the same, so 3, but now it's going to be negative 3. 3, negative 3. Okay. So this is going to be d prime. Then c, again, same thing, just make it negative. D prime and b prime, same thing, just make it negative. Okay. Okay. So then this is just reflected over the x-axis, okay? So that is what your new image is going to be. So and actually after the second transformation, it's called a double prime. So a double prime is at 2, 0. B double prime is at 7, negative 2. C double prime is at 5, negative 5. And D double prime is at 3, negative 3. Okay, so those are our new points after our sequence of transformations. Okay, and the thing about a sequence of transformations is that it's always going to be a rigid motion. It's going to be the same object afterwards. That's what we're looking for. Okay, so that's what we're doing, is proving that figures are going to be congruent by a rigid motion, which means their size and their shape, it does not change. It's just going to stay the same. It's just going to be moved in a different position. Okay, so 2 figures are going to be congruent, which means they're same, okay, if they are exactly the same shape and size. And congruent figures are formed using those rigid transformations that we talked about before. Translations, reflections, rotations. Okay? Those are the only 3. Okay, and so figure FGHJ was reflected and translated to form the figure F double prime, G double prime, H double prime, J double prime. So that means that they are congruent. Okay, because it used a reflection and then a translation. So in this case, for this example, you're determining if these two figures are congruent. And if they are, then we're going to name the transformations used to form the image. So I want you to pause this and try to determine what the two transformations are that got this figure to this figure, okay? Did it reflect it twice? Are they congruent? Do they have the same size and shape? Those are things you want to ask yourself, okay? So I want you to pause this video, and that's where I'm going to leave you for today.